Hi, I'm going to be presenting lesson 510 to you today. This is basically a problem-solving chapter or section of the chapter. You know most of what you need to know in order to be successful with this lesson. One of the skills you have to do is use a formula, and you may or may not be familiar with the formula. It's a pretty simple one, and it involves percent, and it's the idea that interest equals the principal times the rate times the time. And let's talk about what each of these terms means. Interest is money that you earn or that you have to pay for the use of money. So if you want to borrow money, you'll have to pay the lender back everything that you have borrowed, in addition a little bit extra, or it could be a lot extra depending on what the interest rate is and how long you take to pay it back. The longer you use the money, the more you pay. The higher the interest rate that they ask, the more you pay. So a simple example is if you need $10 and you ask your best friend to lend you $10, and he says, "Oh, sure, I'll do that for 10% a day." And so you borrow the money, and then the next day you owe him the $10 plus another dollar. Because 10% of 10 is $1. 10% of $10 is $1. That would be an exorbitant interest rate, would be equivalent to 3,600% per year. So you'd better pay him back pretty quick, or actually he would probably like it if you took your good old time paying back, because he can make a bunch of money off of you. The rate is the annual interest rate. Annual means yearly. So we're going to use pretty simple examples. There's more complicated formulas that are involved for compound interest. But for our purposes, the R in this formula will be the interest rate, so that'll be a percent. And it always has to be an annual percent. Principal is the amount of money that you borrow or that is lent. And T is the time in years. Since we're saying like 3% per year, then the time has to be in a year. And if the time is given in months, as it will be in some of the problems, you have to convert that to either a fraction or a decimal number representing what part of a year it is. For instance, if it's 6 months, you could use, for T, either has to use a half, because 6 months is half of a year, or you could use 0.5, 5/10, whichever is most convenient. And then it's a pretty obvious fact that the total amount that you either earn or that you owe is going to be the amount that was lent or borrowed plus the interest that is earned on the money. So, for example, if you pay your friend back after 1 day, his total amount is going to be $11 because he gets the interest and you pay him back the $10 and the total amount you owe is $11. So let's look at a couple of problems, and they're both going to be off of the spread that you have problems on. The first one's going to be on page 124, number 2. And a girl named Jasmine borrows, and she either borrows money or she's, let's see, let me take a look at it again. Jasmine, it's number 2. Jasmine invested $1,000 for 3 months at an annual rate of 8.5%. And how much did she receive in interest after the 3 months? So this is exactly what you should do. You should say the principal, and fill that in the rate. What's that in T? What time is it? And then you'll know that her interest is going to equal these 3 numbers multiplied together. So the principal is $1,000. That's how much she invested. Her rate was 8.5%, or 0.085 as a decimal number. And the time is 3 months. Whoops. 3 months. Or 3/12 of a year, which equals 1/4. And if you want T, you can use 0.25. Because 1/4, as you have memorized, 1/4 is 25/100ths. It's actually probably going to be pretty convenient to use 1/4, and I'll show you why in a second. So we have to figure out how much she has at the end of 3 months. So we're going to have to use the thing I just erased, that the total amount is going to equal her interest plus the principal. It's going to be $1,000 plus whatever interest she earned. So we have to use this formula to figure out how much interest she got. So her interest is going to equal the principal, $1,000, multiplied by the rate, which is 0.085, times multiplied by the time. And I'm going to go ahead and use 1/4. And I'm going to do a little bit of mental math with this. Because this is all multiplication, we could rearrange it and group it however we wanted to. And it's very convenient to group 1,000 and 1/4 together, because you can pretty quickly calculate what 1/4 of 1,000 is. Probably you can do that in your head. You know, 1/4 of 100 is 25. 1/4 of 1,000 would be 10 times that, or 250. So it's going to be 250 times 0.085. And you either have to use a calculator or a pencil and paper to figure that out. Since I don't have a calculator and I want you to see how we do this, I'm going to do it on the board. 250 times 0. Move that over a little bit. 0.085. 5 times 0 is 0. 5 times 5, 25. 5 times 2 plus 2 is 12. And next to 0 to get started here. 8 times 0 is 0. 8 times 5 is 40. Carry the 4. 8 times 2 plus 4 is 20. 0, 5, 2, 1, 2, and 1, 2, 3 decimals. 1, 2, 3. So how do you interpret this 21.250? Remember, it should be, it's 8.5% of $1,000. I mean, one common sense way to interpret it's $21.25. So she's going to have $21.25 added to her $1,000. So that's pretty easy to calculate. 1,000 plus 21.25 would equal $1,021.25. And that is how much money she has after 3 months. So she just leaves her money sit there for 3 months and gets $21 extra. If you're patient and you have a good interest rate, you can let your money work for you. The next problem I want us to do is, I actually have a red star by this problem on page 125, meaning you might not know right away how to do this problem. You actually have the skills to do this problem, but it is a little tricky. And it says that Caleb paid $22.60 for a skateboard. He used the coupon for 20% off what was the original price. So originally it was priced higher than $22.60, and he had about a fifth of that was taken off. I can think of a couple of ways to do this, but not a really obvious way with the ways that you've been taught and how to solve them. You could do it with proportions, you could do it with an equation, you could draw a picture of it and probably figure it out. I want to take the approach that the original price represented the whole thing. It was 100%, and the 2260 is just part of that. So 2260 is part of the original price, which is what we're trying to figure out. So if we can use the part to whole equals the percent, that's kind of how we're going to approach this one. So we don't know that. Now this is the tricky part, because you'd be really tempted to put a 20 up there. But if you think about what percent of the original price is $22.60, and that's why this makes this kind of a challenging problem. $22.60 is not 20% of the original price. Can you figure out what percent of the original price it is? It was 20% off, and the rest of it was on. And the whole thing is 100%. So what percent of the original price is he paying if you take 20% off of the original 100%? You probably have it by now because I kind of messed around with that. It's 80%. So if you solve this, you'll know what this would represent the original price. So 80N, cross multiplying, would equal 2260 times 100, divided by 80, divided by 80, take a 0 off here right away, multiply that by 10, multiply this by 10 before we do any more reducing. We just kind of shift the decimal here. We can get rid of that. That was pretty quick. Hope you got that. So you can pause it, look back at it. I don't really need that decimal anymore either. So really what I have is 226 divided by 8. If you would guess at what this was, if you knew the facts, that he paid $22.60, which was 80% of the original price, what would you think was reasonable? Because you should be thinking ahead, because you want to know if your answer makes sense. Obviously it was priced at a price higher than $22.60. Would it be, if he had 50% off, the original price would have been about $45.20. So originally it had to be less than that. Somewhere between probably $25 and $30 would be a good estimate on this one. 8 goes into 22 2 times, remainder 6. 8 goes into 66 8 times. And we might be running out of space down here. I'll have to put a decimal in next to 0. 8 goes into 22 times, remainder 4. And 8 would go into 45 times, so I didn't even show that because I'm sure you couldn't see it. $28.25, which is reasonable to think that would be the original price. If you take 20% away from $28.25, you'll get $22.60. I did mention, and I didn't practice this method, so I usually like to try to practice before I put problems up, but as I was working on this, it occurred to me that you might be able to do that problem this way. 20% off, which is a fifth, which means you could divide the original price into 5 equal parts, and let's see, the 22, what he paid, the $22.60 would occupy 4 of these parts. So this is the 20% that was knocked off of it. So this is 20%, I'll just fill them in. This is the percents, and it all adds up to 100%. Again, he took off 20%, and this is what was left. So each one of these sections would be whatever 4 divided by into 2260 is. And I know it's going to go evenly because you can divide 4 into 60, so that's a good thing. 5. Bring the decimal straight up, and the dot that separates dollars and cents. So each of these sections is $5.65. And if I multiply that by 5, I should get to $28.25. If it doesn't, I'll have to do the whole video over again. 32, 28, 25. Wonderful. So, that's a way you can think of problem solving. Sometimes you have to think out of the box and try to figure out, what do I know? How can I draw a picture of it to solve it? And but try to think of the ways in this, when you do the spread, of how you can use the part to whole equals the percent, how you can use interest equals principal times rate times time. Can you use an equation? Can you use a formula? Think of the various ways, the skills that you have to solve problems, and polish them up here.